Thank you, Mr. Chairman. My first question is, how frequently do these observable events happen? You know, like when we talk about storms and floods, 50-year storm or a 50-year flood, 100-year flood, this event that you observed, from probability, how soon can we expect to see one of that magnitude or larger again?
Very soon.
Like 5 minutes or 5 decades? Or?
Well, let me tell you, the analysis that we presented was the analysis of 1 month of data taken with the 2 detectors that only had 16 days of effective time when the 2 detectors were working together, and we need the 2 detectors to confirm the signal. And we saw 1 event in 1 month. Of course, you could say you can.
Well, that either means you got really lucky or your instruments aren't working, or, I mean, it could mean a lot of things. So.
That's right, that's right. So we can only predict from that 1 month of data. We can only say we saw 1 event in 1 month. But we have taken 3 months more of data that we are still analyzing, and everything we see is consistent with what we saw there. And we are going to take more data in the future. And from the theories that we derive, even from this just 1 observation, we have a predicted rate that will mean at least a few a year.
Dr. Shoemaker, you're from the university I graduated from, so I'll give you.
Greetings.
Go ahead.
So one other thing to point out, though, I mentioned that we're at 1/3 of the sensitivity we believe our instruments can achieve with just doing tuning. A really neat thing about gravitational waves, it's an amplitude phenomenon. It falls off as 1/r, not over 1/r squared, the distance from the source to us. If we can increase our sensitivity by a factor of 2, the number of sources within reach goes up as 2 cubed.
So I was going to ask you about that. You said it's going to increase by a factor, or it's going to increase by 3. Did you mean 3x or 3 orders of magnitude?
I mean 3x. That is to say, we'll reach 3 times further out.
Okay.
But that means that the effective, that means the effective rate will go up by 27 if you cube 3. And if we saw 1 event in 30 days of observing, that says we might get to the point where we're seeing an event every day if this 1 event we saw is representative of the rate. So I think we can see that there's a lot of progress in the future that we can go to increasing the rate.
And that's just for binary black holes.
Gotcha.
We still haven't seen neutron stars, and we expect to see quite a few of them when we're at this per year when we're at design sensitivity. We talked about supernovas before. They are the ones that are going to be hard to see. We're going to have to get really lucky to see a supernova because they're just not that strong of an emitter.
One of the questions I did want to ask Dr. González, you touched on it. Did you remember to leave it on when you came to the hearing? Like, what is the duty cycle? How frequently is this collecting data? And is that, I mean, maybe we've already observed things we don't even know yet, and people just need to sort through that data. Maybe we've already observed simultaneously something that we saw in the electromagnetic spectrum, but we just don't know it yet. Is this thing turned on now?
It is intermittently, but for diagnostic purposes, we are not taking data in coincidence. But we have plans to take more what we call engineering runs, opportunistic engineering runs. We will have another observing run with the 2 LIGO detectors starting in this late summer, early fall, perhaps July. And that's how we will know what the rate of these binary black holes and perhaps other events will be. But let me say, you asked me if I remember to leave it on. It's not me, and that's the strength of having 1,000 people working on this.
Right.
There are 200 people in the LIGO laboratory, and they are the ones who not only keep the detectors on, but they improve them every day.
I have a question I want to make sure I get to ask. What are the sources of noise that you have to contend with? You know, like I imagine our sun is doing something. There may be nuclear tests here on Earth that are causing seismic. Maybe talk radio is interfering. It's a big source of noise, but what are some of the noises you've had to filter out?
Let me say what the basic noise sources are. One of them has to do with the sort of quantum effects that Dave Reitze was talking about. We use lasers, and the lasers emit photons in a statistical way. So there's a fluctuation in the number of photons. So there's a fluctuation in what we use as our measure of where the masses are.
Can you get smaller photons?
You can, the thing to do is to get more photons,
Okay.
turn up the laser power. The next thing to do is address these questions of thermal noise that I mentioned earlier on. Everything is jiggling around due to Brownian motion, and the way we address that is to choose materials that have very, very low internal losses and squeeze all of that jiggling into a very narrow frequency band. Lastly, you were talking about seismic motion. We built, and that's one of the really big improvements of advanced LIGO or initial LIGO, a system of seismic isolation, which makes it so that we're effectively independent of the environment around us during normal weather conditions. We still can get knocked out of lock when there's a lot of wind. There was a tornado down in Louisiana just yesterday. So there's...
One last quick question before I yield back. When you get this third detector, does that just improve the reliability of your data, or does having a third point on Earth give you an ability to triangulate? Dr. Crim, you were shaking your head. Maybe you could...
All of the above.
All of us are shaking our head, yes. That's to both.
Both.
But it will give you a bigger picture of what's going on. Can it do that?
It gives you better localization, so you will better pinpoint where the source comes from. But also, if you have 3 detectors, you need 2 to see a signal. If you have 3, you can have one on and the other 2, and then you will still see the signal. With only 2 LIGO detectors, if one is down, we are in the dark.
Gotcha. Thank you. I yield back. I could ask 100 more questions. It's very fascinating. Thank you.
Thank you, Mr. Massie. The